Paradoxes are like riddles for our minds. They present us with seemingly logical arguments that lead to absurd or contradictory conclusions. One such paradox, intriguing mathematicians and philosophers for decades, is the two-envelope paradox. This thought experiment challenges our fundamental understanding of probability and decision-making, leaving us perplexed yet strangely drawn to its captivating mystery. The two-envelope paradox is a classic example of how our intuition can sometimes mislead us. It highlights the importance of careful analysis and the dangers of jumping to conclusions based on seemingly plausible arguments. In this essay, we will delve into the heart of this paradox, examining its origins, dissecting its logic, and exploring its implications for our understanding of uncertainty and decision-making. Imagine you are presented with two sealed envelopes. You are told that each envelope contains a certain amount of money, and that one envelope has twice as much money as the other. You are then asked to choose one envelope at random. So far, so good, right? Now comes the twist. After selecting an envelope, but before opening it, you are offered the opportunity to switch to the other envelope. The question posed by the paradox is this: should you switch envelopes? At first glance, it might seem like it doesn't matter if you switch or not. After all, you don't know which envelope contains the larger amount. However, a seemingly compelling mathematical argument suggests that you should always switch, as it appears to guarantee a higher expected gain. This is where the paradox truly begins to unfold. The argument for switching envelopes hinges on a simple calculation involving expected value. Let's say the amount of money in the envelope you initially chose is represented by the variable x. Since the other envelope is known to contain either half or double this amount, it must contain either x divided by 2 or 2 times x. If we calculate the expected value of switching, we get 1/2 times x divided by 2 plus 1/2 times 2 times x equals 5x divided by 4. This result suggests that the expected value of switching is always 1¼ times the value of the envelope you currently hold. In other words, it appears as though you could magically increase your winnings by simply switching envelopes. This is where our intuition starts to scream foul play. Section 4. Unraveling the misconception. The flaw in the above argument lies in the assumption that the amount of money x in your chosen envelope is a fixed value. This is where the paradox tricks us into making a false assumption. In reality, the amount x is not fixed but is dependent on the process by which the amounts in the envelopes were determined. To illustrate this, let's consider two different scenarios for how the envelopes were filled. Scenario 1. A fixed amount, say $100, is placed in one envelope, and then the other envelope is filled with either $50 or $200, with equal probability. In this scenario, if you initially picked the envelope with $100, switching would indeed be disadvantageous. Conversely, if you initially picked the envelope with either $50 or $200, switching would be advantageous. Scenario 2, an amount x is randomly determined, and then one envelope is filled with x and the other with 2x. In this scenario, the expected value calculation for switching holds true, but it doesn't actually provide any new information. The paradox arises from conflating these two scenarios. The mathematical argument for switching implicitly assumes a scenario like scenario 2, but the way the problem is typically presented often leads people to think of a scenario like scenario 1. Section 5. A glimpse into history. The two-envelope paradox, though seemingly simple in its formulation, has a surprisingly rich history, with roots dating back to the early 20th century. While variations of the paradox have been discussed earlier, its modern formulation is often attributed to the mathematician Maurice Kreyszig, who presented a similar problem in his 1937 book on mathematical recreations. However, it was in the latter half of the 20th century that the paradox gained significant attention, sparking numerous debates and publications in philosophy and decision theory. Notable contributions came from philosophers like David Lewis and decision theorists like Daniel Ellsberg, who explored the paradox's implications for our understanding of probability, utility, and rational choice. Section 6. Real-world implications. While the two-envelope paradox may seem like a purely theoretical exercise in mathematical trickery, it holds valuable lessons that extend beyond the realm of abstract puzzles. At its core, the paradox highlights the importance of carefully defining the problem space and understanding the underlying assumptions when making decisions under uncertainty. For instance, In finance and economics, where decisions often involve weighing potential gains and losses, failing to recognize hidden assumptions or dependencies can lead to flawed investment strategies. The paradox serves as a reminder to always question seemingly obvious conclusions, and to dig deeper into the underlying structure of a problem before making crucial decisions. Section 7. The paradox's enduring value. The two-envelope paradox, despite its apparent simplicity, continues to fascinate and challenge our thinking about probability, decision-making, and the nature of paradox itself. While there's no universally agreed-upon resolution, grappling with the paradox forces us to confront the limitations of our intuition and the importance of rigorous analysis in the face of uncertainty. Ultimately, the two-envelope paradox serves as a powerful reminder that even in seemingly straightforward situations, hidden assumptions and subtle nuances can lead to unexpected and counterintuitive results. By embracing such paradoxes, we can sharpen our critical thinking skills, deepen our understanding of the world around us, and perhaps even unlock new insights into the nature of knowledge and belief itself.